Hydrogen is used in aviation primarily through two methods. The first method involves fuel cells that convert hydrogen into electricity, which then powers electronic motors to drive propeller aircraft. This approach only produces water vapor, making it incredibly clean. The second method is through direct combustion, where hydrogen is burned into modified jet engines. Although it requires significant adjustment to reduce emissions, to provide a variable alternative to traditional fuel while maintaining the power needed for larger aircraft. There are significant challenges to address. First, hydrogen storage requires extremely conditions, either highly compressed gas or cold liquid, making it costly and adding extra weight to the aircraft. Second, the refueling infrastructure is still undeveloped, requiring major investment in airports and transportation systems. Lastly, safety is the critical issue, as hydrogen is highly flammable and requires strict conditions on storage and use. Those challenges must be resolved to unlock hydrogen's full potential in aviation.
Let's talk about the advantages of hydrogen. Hydrogen is produced by water, so we don't need to worry that the resources may run out of use someday. Also, hydrogen energy is highly energy efficient and has zero emission. So why don't we create a cleaner future ourselves? Now, let's move on to the next section. How is hydrogen gas formed? Hydrogen, the lightest and most abundant element in the universe, was formed during the Big Bang and make up about 75% of ordinary matter. On Earth, it can be produced through the industrial process, such as steam methane reforming or partial oxidations of fossil fuels, or by reacting metal like zinc with acid in laboratory. Cleaner methods, such as water electrolysis powered by renewable energy, are being developed to make hydrogen a key player in the future of clean energy. To make hydrogen-powered aircraft in reality, there are 5 ingredients required. First, hydrogen fuel, followed by the storage tank, fuel cells or combustion engine, electric motors, and infrastructure. Now, let's introduce them sequentially. First, hydrogen fuel. Hydrogen can be stored as a liquid or a high-pressure gas form. This fuel powers either combustion engines or fuel cells, which converts the hydrogen into electricity. Storage tank. Since hydrogen is lightweight but has low energy density, it must be stored in an advanced tank. These tanks need to hold hydrogen at high pressure or cryogeneration temperatures while remaining safe and efficient. And the fuel cells or combustion engines. Depending on the design, hydrogen is either burned in a modified jet engines or used in fuel cells to produce electricity. Both systems must be highly efficient and lightweight. And the next one is electric motors. For fuel cells powered aircraft, electric motors are used in drive the propellers or fans. These motors need to be powerful yet energy efficient. And the last one, infrastructure. To support hydrogen powered plane, specialized refueling infrastructures is essential. These include refueling stations and the transportation of hydrogen to airports, which requires new logistics and facility. These are the key components required to develop and operate hydrogen-powered aircraft, paving the way for sustainable futures in aviation.
So
So now I'm going to briefly introduce you about the pros and cons about hydrogen fuel and the main concern it may face in the near future. At the beginning, there are three main problems we should deal with before we make hydrogen fuel come true. First, it is about the cost. The hydrogen fuel may cost us far more higher than the fuel that we currently use around the aviation industry. It is easy to associate with its produced process. Correct, it is very difficult to produce and save. Although it may take us a while to deal with those problems, there is still no denying that hydrogen fuel is coming to us. The future belongs to those who prepare for it today.